Hey everyone, and welcome to our next live session on our YouTube series for TCS as well as Infosys. So, I welcome everyone joining into the live session by Quant Masters here. So, good evening, guys. Now, before we begin, as always, I just want to confirm if you guys can hear me properly and see the screen. If so, any one of you can just let me know. You guys can just let me know by chat, either stating yes, we can hear, AV, or anything works fine. So everyone's able to hear. Okay, I've seen a couple of messages already. Glad to hear that. You guys can see the screen and hear. Perfect. So let's go ahead and begin our session today. Now, I had before I start with our problem, before we start with our problem to solve for today, we had one particular question in our last session. That was, how do I add two strings and return their integer value? So I'm going to take very quickly, since we had this at the end of our session yesterday. I'm just going to take this up and show you how to do it. When you do get this question, you generally expect this question as a function. That is, you generally expect this question in a function format. So let me just quickly show this to you guys. Add two strings as decimal numbers or integer numbers, whatever you want to call. So I hope the student who has asked is also present. I hope so. If you are, you can just send one message over live chat so we can get to know that you are available as well. So let's quickly take this scenario. Now, here's the thing. There's going to be two strings. Alright, so I'll just take string str1 and str2, two strings. We're going to read these two strings. Let's call them as str1. We're reading it, and then we're reading str2. Now, once we have read these two strings, we just need to call add of string 1 comma string 2 and return the sum of them. That's it. So when you're given only the function like int sum of string 1, sorry, string str1 comma string str2, here's what we need to do. Very simple logic. We just need to add these two strings and return the resulting value. So let's try doing this. First step, for us to do this, we need to use C language's standard library header file. This is an important header file for us because we have an inbuilt function in C as well as C++, because C++, as we know, is a superset of C. We have an inbuilt function available which converts string to integer. That is like this. Return a to I of string 1 plus a to I of string 2. That's it. A to I is a simple function which converts our strings to their equivalent integer formats. Let's try this. Let's try running this. So it says there's one, very sorry guys, I've used sum here, but I've used add here. So let me make it sum in both places. So that's where we had an error, and also this is supposed to be string. So let's just modify that little part. Now let's compile and run. Again, there's supposed to be one particular error here. Yeah, right. See guys, when you use A to I, you need to input character array. You cannot use string. Please remember, I have one question, how to do it in Python. Very easy logic. Python is much easier than the others. I'll explain, not to worry. Alright, so remember, if you want to do string to integer in C++, A to I will not work because A to I particularly works for character array, array to integer. A to I works particularly for character array to integer. If you really want to use strings to integer, we need to use a different logic here because our input is string, not character array. If your input was character array, you can do this. Since your input is string, you need to use stream header file. Stream stands for string stream. In the string stream, you can get the result of any, let's say, number or any value as an integer using string stream. That's what we're gonna do. So what we'll do here is, let's say, take this example to understand how string stream works. Now I have these two strings, str1 and str2. I have to take both of these into string stream. First, let me take it into string stream. So I'm gonna take string stream. No, we can't use int directly. That is possible in Python. Yes, as Swami pointed out, int directly is possible in Python, but here we don't have the way to do that. Now we can either use string stream. I'll explain two methods so that everybody is able to know both methods. String stream, you can give your integer value like int of whatever integer variable of your string 1 and everything like this. If you don't want to use string stream, if you want to find something simple like this, you can include your string header file, which has a couple of functions called s2i. That's it. s2i is inbuilt function within C++, which you can use like this. And if you run this code, and if I enter 125 and let's say 375, it's supposed to give me 500. Both values are entered as strings. We have added the strings and returned the sum of the strings. Very simple program. We were able to do it in just one line of code over here in C++. Really not difficult. Now what about Java? What do I need to do if I want to do the same in Java? Again, everywhere it's a single line program. Do not worry at all. Everywhere it's a single line program. I'll take two strings. String str1, comma, equals scanner dot next line. Similarly, string str2 equals, I have one question. Do we have same function in Java? We have a similar function. I'll explain. Alright, sc dot next line. Now, the program we are going through here in short, before we go ahead with our next program, before we go ahead with our Roman numerals, is one of the questions that was asked from your end. That is, how to add two strings and result and give the result in integer form. This was the question that was asked. That's exactly what we are doing over here. We solved this in C++, where we have just used s to I to convert from string to integer. Now we're just doing the same thing in Java. I think okay, Sakshi was the person who asked that question yesterday. I'm not sure. I'm assuming so. I think so. You can confirm if so. No worries. So let's go ahead and try working through this. Let's go ahead and try solving this. We are reading two strings, str1, str2, and we're calling, let's say, some strings, which is going to return an integer. We're going to pass string 1 and string 2. That's it. Now let's receive them here. Our function name is sum underscore strings, where we are passing two values, that is string str1, comma, string str2. Now, pretty simple. If you want to store the result back, you just need to perform, let's say, int result equals integer dot parse int of str1 plus, again, integer is our wrapper class dot parse int of str2. That's it. Once you're done with this, you just need to return result. Let's see if it works. We're not sure whatsoever. Let's see what happens. So this is Java C code.java. Now let's see what exactly occurs here. What error could possibly happen? No errors. So let's try running this. Java code. I'll give 103 and 375. Some values. I'm getting 498. Simple. We got to take two strings as input. We got to convert them to integer. We got to add them. Done. Simple logic. Really simple logic. You can solve this program in just one line. Even in Python, we know this because if input is string, like let's say string 1 equals input like this, and string 2 equals again input like this, and if you're calling some strings of string 1 comma string 2, all you need to do here is a pretty simple logic. You just need to create your function called SumStrings, read the two strings str1 comma str2, and here just return integer of str1 plus integer of str2. That's it, that's all. And you just need to print sorry, we just need to print the resulting value. That's the whole logic. Sounds simple. So let's compile this, let's run this, or interpret and run this. So we got our result. So everywhere it is just one line function. That's it. String to integer conversion is a pretty easy thing. So that's clear. That's very easy and clear. Now, with this, let's quickly move ahead to our next problem that we want to do, which is called Roman numeral to integer conversion. I have one of you stating I work daily on programs but still not able to pass all test cases in interview in limited time. Here's the thing, see, when you look at passing test cases, each program has different scenarios. You have to think about every single possible input, whether your program solves it or not. You literally have to think of every possible input and compare and check if your program literally is able to solve it or not. So it's not a solution for all programs that I can give together. It's a solution we have program wise. It's a solution we have for one program at a time. So to the question of Swami is finding it difficult, a lot of us do find it difficult to clear test cases. I get that. So one of the best ways is check all different inputs. If it's an array wise, check no elements, check one element, check increasing order, check decreasing order, check all different kinds of inputs. Trace out whether your program works for all of them. And that's how you will get to know if you're losing out on some test cases. Because in interviews, they will not show you which test case you went wrong in. They will not show you that. They will just tell you 6 out of 9 test cases passed or 5 out of 20 test cases passed. That's all they will state. So it becomes completely your choice, your logical ability to try every single input, every single different kind of input and see where your program is going wrong by tracing it out manually. That's where we'll get to know. And if you can solve this, if you can figure this out before writing the program, that will help you even better, because once you start writing the program, you already have solved these test cases beforehand. So you don't have to worry later on by changing the program. I hope that gives you an idea. So from next time you solve programs, from next time you work on programs, take a couple of minutes, look at all different inputs and see whether your logic works for it. And then figure it out. That is how I would always suggest. Alright, now let's go ahead to our next question, that is Roman numeral to integer. Now there are a couple of constraints that are put up. Constraint is 1 less than equal to, that is your Roman numeral, input Roman numeral will range from 1 to 3999. So this is the range that they're saying. It will stay only in this range. They will also give you a few inputs, like which is the symbol and what is its equivalent integer value. Symbol I represents an equivalent value of 1. Similarly, symbol V represents, as you know, an equivalent value of 5. Similarly, symbol X represents an equivalent value of 10. Likewise, you have for 100, 100, 500 and 50, 100, 500,000 as well. So if you guys remember, L will point for 50 and M will point for, if you guys remember, there's C and D and M. Sorry, I should have written C first. and then D, and then M. So C will stand for 100, D stands for 500, and M stands for 1000. Now, this is a very commonly asked question. This is a very common interview question that we can expect, because I have seen this in a lot of interviews where they just give this and they want students to figure out and solve this. It's a very, very common question. Now, let me tell you how we can solve this, how we're going to go ahead with this. So, I have one of you asking when will be the next batch starting from. You can just get to know our batch details and everything through contacting with the number in the description of our channel. Please do that. There will definitely let you know when we're going to start each batch, which is the next time schedule will have and everything. You can immediately get to know over there. All right. So you can do that at Rahim. I have one more question by Swami. Using dictionary, we can solve this. Absolutely right. And as Swami pointed out, that's the best logic. I'll tell you later on why I'm gonna use this. That's the best logic. That's the best scenario to solve this. That's the best method to solve this, because if you use something like dictionary, you're gonna save so much time. You're going to save so much time that your program will be at least 20 to 30 times faster than a regular program. Now, what is this regular program? I'll explain. First, let us try how to manually do this. Then we'll think of this. I have one of you, Shreya, stating that we can use map in C++. Absolutely right. So there are a lot of different data structures which we can use. We have map, we have set, we have linked list, stack, queues, a lot of other things. So that's why we use certain things like maps. And as Swami pointed out, right now, time complexity is big O of 1 in dictionaries. Absolutely yes. That is how we'll be saving a lot of time. Now, I'll just take one small example. I'll take this MCM XCIV. Let's take this small example. I hope many of you may have heard of MCMXCIV as to why it is actually a famous Roman numeral in real life. If you have not, it's an interesting thing for you to learn and work about. It's not something we need to learn right now, but it's something interesting, right? Anyway, let's go ahead. Let's not worry much about this. Let's move ahead. It represents the year 1994. It's gonna give you the value 1994 if you calculate this. But what we need to do is convert this into integer. Now let's start this logic. When I have a Roman numeral, should I convert right to left or left to right? Let's think of this. If I have VII, I can say 5 plus 6 plus 1 plus 1. I can make it 7. So I can work on it right to left to right also. I can work on it right to left also. Like 1 plus 1 is 2, 2 plus 5 is 7. We can work on it in either way. I prefer to work right to left because I don't want to do too much checking of next value. It is easier for us to check the previous value and go ahead. Both will have same logic. Do not worry. You just have to change some slight plus and minus and index value, but both will do the same. Now I'll give you an example here. Observe this, guys. I'll take 4, 5, 6, and let's say 15. Now, in this case, right side value is greater than left side value. When right side value is greater than left side value, I'm supposed to perform 1 minus 4. When I only have one value, I will write it as 5 itself. Sorry, 1 minus 5, not 4. Because 1 and then 5. Sorry guys, not 1 minus 5. 5 minus 1. Right side value minus left side value. So when I have IB, which is representing 4, I'm supposed to perform 5 minus 4. When I have just B, it represents 5. When I have BI, right side value is lesser than left side value. So I'm supposed to add them. So that will be 5 plus 1. When I have XV, again 15, right side value is, left side value is greater than right side value. So we'll add them, that is 10 plus 5. So we have two different logics. The value to the left is either lesser or greater. So according to this, we need to use different logic. When the value to the left is lesser, I need to perform minus. right side value minus left side value. But when the value to the right side is greater, I can just add. This is the simple logic we need to do. Now let's take a look at this. Let's consider this as our string and let's see where we're gonna do. I'll take this as index. So I think it went to an emoji. I think I'm unable to point to text. Okay, there's some slight issue. Hold on, guys. Right, check this, guys. Perfect. Let's say I is the index. So I'll just do one thing. Perfect. At least this is a larger value. Perfect. So let's say this is our index. Now we need to start from last index, that is whatever is before null character, until when? Until we reach the index 0. This is our entire logic. This is what we need to do exactly. So let's take a look at this and let's see how we're going to figure this out, how we're going to solve this out, what are we going to do in order to work this problem through. Let's start right to left. Now, please observe here, guys. What's the first thing you have? V. Now, I'll just remember that it is 5. What's the value behind it? I. I represents, remember, we need to compare this. For each character I get, I need to keep a array or something. I need to somehow find this, somehow remember this. If the character is I, return 1. If the character is V, return 5. If the character is X, return 10. If the character is L, return 50 and everything. We need to search for this particular character in these symbols and return accordingly the value. That is what we need to do. So for each character, I'm going to return that value. After returning the value, I'm going to go to the previous character. When I go to the previous character, I'll check, is the value returned by the previous character, which is 1, is it less than V or greater than V? It is less than V. If it is same also, we need to just add. If you guys remember this, like take this. This is 2. We are adding 1 plus 1. This is 3. We are adding 1 plus 1 plus 1. This is 20. We are adding 10 plus 10. So when the character is same, we need to add. When the leftmost character is larger also, we need to add. Only when left character is lesser than the right character, we need to subtract. This is the exact logic that we need to follow. Now observe here, guys. For 1, I am getting 1. Since I'm getting 1, what do I do here? Can you guys think through and let me know? What is the step I should take over here? Any guesses, guys? Let's see how many of you will be able to tell me. Since 1, of course, we're supposed to perform subtraction. I have one question. Will there be any test case for invalid Roman numerals? In this question, which was asked recently in interview, there wasn't any such case. But if there is such a case, it's very, very easy to do, not to worry. All we need to figure out if there's a character apart from this. If there's a character apart from this, we just exit saying invalid or exit returning 0 or something like that. That's all you need to know. If there's any character apart from this, you just exit. That's the whole idea. Now, we don't need one more variable. We're going to be able to do this with just one variable because I can compare I with I plus 1 or I can compare I with I minus 1 or anything like this. We can do that, right? So we'll compare index I with I plus 1 or index I with I minus 1 and we'll work on this. I have one question also for, yes, 4 as well. Even in this case 4, when the numbers are same, we add them. So 1 plus 1 plus 1 plus 1. So absolutely right. So let's go ahead in this case and see. str of I is lesser than str of I plus 1. Since str of I is lesser than str of I plus 1, whatever is str of I plus 1, I'm going to subtract this and I'm going to store the result as 4. This is my result. Done. Now let's reduce I. Now, what about this str of I? Is it greater than or less than? Again, I need to do the same thing. Is it greater than or less than its next value? C represents 100. C, of course, is greater than 1. Of course, 100 is greater than 1. Since it is greater than 1, this is our result. I'll just take a variable called result. So I starts from last second index. Let's assume I starts from last second index. We're going to compare if str of I is greater than, or sorry, is lesser than str of I plus 1. If it is lesser, then we need to subtract. If it is equal or greater, that is in else case, we just add. So if str of I is lesser than str of I plus 1, we're going to take the result, which is initially 0, because we are adding, right? Additive identity is 0. If you are multiplication identity should always be 1. So whenever you are going for additive identity, please make it 0, because when you are adding first time, you should get the same result as whatever you have added. In multiplication, just make it 1 by default. That's our whole idea. That's our whole scenario, whole logic to work with. Now, with this done, let's go on to the next part. Let's go on to the next case over here. Now, observe this, guys. Please note and observe this very, very carefully. I'm comparing string of I and string of I plus 1. Is string of I greater than string of I plus 1 or equal to? No, it is lesser than. Since string of I is lesser than string of I plus 1. So, I'm just going to write. We're going to subtract result minus result equals result or string of I plus 1 minus string of I. Whatever is string of I plus 1, I'm going to have to subtract with string of I and put up. Now, initially for that purpose, this whatever is last value, that I will store in result. I can do this, right? Last value is 5. I will store 5 as a result. So what I'll do here is, if string of I is less than string of I plus 1, I'll take result minus equals string of I. Result is initially our last index, 5. So that 5 is there in result. So when string of I is less than I plus 1, I'm going to subtract this from the result. So when you subtract this from the result, it's going to become 4. Done. Now let's go for the next case. Let's reduce I. Is string of I less than I plus 1? No, it is greater. This is our if condition. Else, since it is greater, what we need to do here is, we just need to add result plus equals string of I. That's it. So since it is greater or equal to, C is 100, so we'll add 100 to 4. This becomes 104. Our result should be 1996. If it is, then our logic is right. Sorry, 1994. Very sorry, guys. Now, X. X is lesser than or greater than? Of course, it is lesser than. X is lesser than our C value. Since it is lesser than, I'm going to subtract it with result. It will become 94. Done. Then, let's go on for M. M is 1000. 1000 is greater than 94. Since it is greater than 94, we'll add it. It's going to become 1094. Then, let's go on for the next one. C is lesser than that. Since it is lesser than that, let's subtract. It's going to become 994. After that, then let's go for the character below it. Now remember, this is index 0. This is the last thing we should work with. This is our condition till which I reduces. Now, M is lesser than or greater than? Of course, M is greater than this. Since M is greater than this, all that we're going to do is a simple logic. We're going to add 1000. It's going to become 1994 here. Is that the right answer? Yes, it is. So if you want, you can definitely go on to Google, perform something like Roman numeral, let's say Roman to integer. If you guys want to do this, you will easily be able to get this. There's lot of online calculators which you can just use to work through. Like, let's say, I'll just give this. We're getting 1994 as expected. That's it. Simple logic. Now, with this idea clear, let's try to create this code. Very simple logic. Really, really not difficult. So I'm just going to take one string. That's it. One string as input. And I'll just call Roman to integer. And I'll just send that string. That's it. That string is supposed to return an integer value by reading a string value. That's it. This is all that we need to do. Very, very simple logic. So let's see if we are able to work through this. We are able to execute this program perfectly as expected. So first thing, guys, observe, there are a couple of other things, there's a couple of very important things that we need to know. Because here, if you guys write it like this, remember, I can have a scenario like this. I can have one more function which will return int value. We can create a function called int value where we'll take a character C. Now, this is going to return, let's say, integer. Now, what I'll do here is, observe guys, if C is equal to, let's say, I, not C in single quotation. If C as character, if C is equal to I, that is or 1 in our case, if C is equal to the character I, then I need to return 1. Similarly, else if, you can write C is equal to, you don't even need to write else because you have if condition, that's enough. C is equal to V, uppercase, anyway uppercase only will be given as input, then you can return 5 and so on. Now there's a problem with this. I'll explain what is the problem here. Now I'll quickly explain this. Now by the time I explain this, I just want you guys to let me know how many of you are you guys familiar with the concept of hashing, hash tables? Let's see how many of you are familiar. So I think most of us who have gone through our sessions would be very, very familiar with it. So majority of you guys can just put in one text if you are or if you are not familiar with it. So I can have a good idea of how many of you are familiar with this concept or not familiar with this concept. Because if you are, then you can solve this in a better way. If you are not, then tough luck. It's going to be very difficult. So yeah, at Swami's question, collision handling happens internally. So you don't have to worry about it. It happens internally. So I'm getting somewhat equal responses, like I'm getting equally no and equally yes. So it's pretty much equal. So let me explain what it is in just a minute, and then we'll go on to our program. See guys, take this scenario. Worst case, let's say in the worst case problem, if my character is M, how many searches are performed here to get to its value? 1, 2, 3, 4, 5, and 6. 6 searches are performed. So in worst case scenario, wouldn't this also add to our problem? Wouldn't this also add to our logic? Or wouldn't this also add to our time complexity? It will, right? This will also add to our time complexity, but I don't want it to add to our time complexity. Because if you observe here, if it takes 6 searches, then every time I'm searching, if there are 8 characters, first I'm doing is I'm going through all the 8 characters. Along with going through all the 8 characters, for each character, there's a worst case scenario of 6 searches to be done. In such a case, my worst time complexity becomes 8 into 6. Or in that case, it becomes 6n. 6n is a very long amount of time. I don't want to do so much comparisons. I really don't want to do such huge amount of comparisons. To avoid that, we can find different searching techniques. If you guys remember, you have linear and binary search. What happens in binary search? You will sort it, you will keep it in a sorted fashion so that your time complexity becomes log n, which is less than n. There's one more method to do this. I'll give you this scenario. Let's say I have elements like 10, 20, 30, 40, 50, 60, 70, and 80. Let's say these are the elements I have. And I want to figure out how to perform search of an element. And let me give you this let me give you this different answer. For those who don't know this, you're going to be shocked at this. For those who know this, it's good to know. We're going to perform searching with a time complexity of 1. We're going to search within one operation. We're not going to take any more operations than just one operation to search. How will we do that? Think of this. What I'm going to do here is, since I have array values 1 to 80, I'm going to create a very huge array where I'll have index 0, 1, 2 up to 10 and up to index 20, up to index 30 and so on. So wherever I have any value 0, 1, 2, all these indices, I'll make them 0. Wherever I have index 10, I'll write it 1. Wherever I have index 20 only, I'll write it 2. Wherever I have index 30 only, I'll write it 3. All other indices, I'll make them 0. So what happens in that case? If input is 10, I'm going to go to index 10. How many operations do I need to do to go to index 10? Only one operation. Since I'm only going to index 10 using one single operation, it will find out the value within it in one operation if it is 1 or 0. If it is 1, then yes, we get the result within one operation that it is found. If I'm searching for, let's say, 7, it goes to index 7. Is index 7 having a value 1? No, because only these indices have a value 1. So when index 7 does not have a value 1, it returns 0. You have performed search in just one operation. Just one operation. Does this make sense, guys? I hope this makes sense as to how it works. Now, in this scenario, in this particular scenario, you are able to find out whether a certain element exists or not. But the problem is size of the array. Size of the array is the biggest problem. To avoid this problem of size of the array, we use something called hashing. Okay, one of you has asked me to just go through this again. So please observe this. Since I have values 10, 20, 30 and so on, what I will do here is I'll create an index of all these elements. Now, index of all these elements, these are the elements of my array. I'll create a big array, and wherever the index is 10, 20, 30 and everything, I'll store the value as 1. Wherever it is not 10, 20, 30 and anything, I'll store the value as 0. So if I want to search 10, I will go to the index 10 and find the value. This is what I'm doing. I hope that Nashra's question is very, very clear. Now, I have one question. Hashing is not recommended by many companies. I'll tell you where it is recommended, where it is not recommended, when it is recommended, when it is not recommended, when to use hashing, when not to use hashing. I'll tell you guys. See, take this scenario. Now, since the array size is too big, I need to reduce the size of the array. I need to somehow reduce the size of the array. So what I'm going to do here is take all these values, perform mod 10. When I perform mod 10, what do I get? I get 1, 2, 3, 4, 5, 6, 7, 8. These are the values I get. So I'll create an array with only these values. Only these values. So for index 1, I'll keep it 1. 2 also it is 1. 3 also it is 1. 4, 5, 6, 7 and 8 is also 1. But for 0, I'll keep it 0. Because 0 is not present. Only 10 to 80 is present. Since 10 to 80 is present, what I'm going to do here is perform mod 10, and wherever I get that particular index, I will make sure it is 1. Now, what happens here is array size is also reduced. If I want to search if I want to search 50, what I'll do here is I'll take 50 mod 10. What do I get? I get 5. 50 mod 10 will give me 5. Sorry, not mod 10. 50, let's say in this case divided by 10. Remainder will be 0 regardless. Let's say quotient in that case. 50 by 10 gives me certain value. Since 50 by 10 gives me certain value, I'm going to go to that value and I'm going to state that whatever is the index of 50 by 10, it's going to give me 1. So generally we work it with remainders. Yes, generally when we work with this, we use remainders, but since I've already written this, I'm just using division. But please note and remember, in real life, this works with remainders most of the time. So that's what we need to know and remember. All right. So let us move ahead over here through to the next part. Now, please observe here, guys. Now, in this case, what happens, let's say if input is 60, 60 by 10 gives me 6, I'll go to this index, it is 1, got it. Now, what if I have something like 62 by 10? Wouldn't this cause a problem? Think about it. Wouldn't this cause a problem? Of course it would cause a problem, right? Because 62 by 10 will also give us 6. It will also say that 62 is also present. So that's not supposed to happen. Then our code goes wrong. So when is like as a question, it will still return 1. That's the problem. So when can we use this concept? When can we not use this concept? Let's think about it. In our question, in our program, we have 1 or I, V, X, C, D and M. This is all we have. Will there be any other input? Will there be any different input from the user? Right? There will be only these inputs. Roman numerals will only consist of this. If there are other inputs as well, if there are other inputs along with it as well, you have to give one more scenario. You have to use else if ladder in that case, and in the end you have to use else return or else exit by printing something or return whatever value you're supposed to. That is what you need to do. But in this case, in our current scenario, we don't need to struggle with it because we are completely sure. I'll repeat. We are 100% sure that in our case, input. Sorry, guys, I forgot L over here. Okay, very sorry, guys. I forgot L, so I'll just add that as well. Right. So L is supposed to be 50. Let's add that. Absolutely correct, as Rahim pointed out. So now let's take a look at this scenario. Now let's take this case. Won't it cause a problem in this scenario? Now it won't, because we have limited inputs, right? And outside of this input, there is no other question. There's no other thing we are comparing with. We have only those inputs. Because according to this, there are no other inputs that are entered. If other inputs are also entered, then there could be collision. Then there could be collision in that case. As I think Swami earlier pointed out, or sorry, Varun earlier pointed out, hashing is not recommended for many companies. Why is that the case? Because one, if you're searching for something else, remember, if you're searching for something else apart from whatever is supposed to be the data, whatever is supposed to be our like elements, then collision may happen. What if you are searching only for the elements? Then no collision will happen. That's exactly what happens here. Here we're going to create a character array using this. We're going to create something called an array here where every index will be all of these value modulus something. Modulus which value? Your computer itself will decide. It will decide that you are supposed to perform modulus with some value so that you get unique result. So for the first one also unique response should be there. For second, third, fourth, fifth, sixth, seventh. For all of this unique result should be there. By taking that unique result, we should be able to find out which is the index directly. That's our logic. So take this scenario. If I may perform mod 17 or mod 29 or some value, your computer will decide by performing mod which value. It will not repeat the function, it will not repeat any value, so that we can create such an array. And whenever you are searching for something, it will again perform mod, go to that index. If such a value exists, index exists, you can use this. So this is how we do it. So for that purpose, we have a concept called map particularly, where we can have these as our key. This is our, let's say, key. And for these keys, we can have values like this, like 1, 10, 1, 5, 10, 50, let's say 100, 500 and 1000. These will be the values for these keys. So we can use this key value pair to get to know. And you don't have to search for a key. You can directly go to a key. You can directly enter a key. That is one way to do this. So followed by this, there are a few other ways to let's say do this as well. Now one thing, guys, please note this, very very clearly. One thing, now If you use switch case also, I'll point out, as Rajat pointed out, yes, you have to use unordered map. So I'll just point out, if you use switch case as well, for a switch case, it's gonna jump directly to that offset. So switch case also resembles the same thing. Switch case also resembles the exact same thing. So you can also use a switch case where time complexity also comes up as big O of 1. But we can't end up creating switch case always. We're just going to use a map here. So for those who don't know about this, I'll just share a link so that you guys can read this, understand how we are going to create this dictionary. You have something called unordered map in C++. It is unordered underscore map, not unordered space, because if I search space, it will of course give me the result, but I want to search the exact thing. So here you go. This is what we're going to use. So if you're interested in learning this, I will also share this link with you over here so you can have a good idea and take a look at it and learn it. Now, if you really are interested, you can definitely go through this. You'll get a good idea. So unordered map has two parts, unordered map, unordered multimap. We're going to use unordered map. Now, let's take a look at this. In unordered map, it says you can have a key value pairs, and this key value pairs, whatever you will have, they will be ordered by a hash function. So that basically means it will perform some comparison, and it will, each element will store two values, key and value, and it will perform let's say search in big O of 1 at maximum. That's exactly how we do this. So you can go through this, look at this, take a look at this, understand how it works, take a look at a few examples so you can get to see how exactly this works very clearly. So this is how you can work through this. Now we're going to create the same thing over here in our example. So what I'm going to do here is just go here. So for me to use an unordered map, I need to include unordered map over here. Remember, whenever you have a constant set of values, I'll repeat, whenever you have a constant set of values to perform search, the values do not change. The values do not change throughout the program. Then you can use hashing. If the values change, then it's preferred not to do that, because due to collision, it may have to repeat and redo everything. So if whatever I've just explained about collision and everything are very difficult for you, it's all based on mathematical operations. You can go through any mathematical tutorial and learn how hash collision works, what it is, and everything in detail. But in our case, let's not worry about it. We just need to know this much. Whenever input is constant, whenever the input is fixed, you're not changing the input anywhere throughout the program. Like in this case, I, V, X, L, C, D, and M. We are not changing that anywhere in the program. So that is why we can keep it as a map. If it's changing, we can't keep it as a map. That's the whole idea. So let's create a map for this in our function here. I'll create unordered map. Now, observe guys, what is the key and the value? The key is a character, the value is an integer. So for every character, I need to get an equivalent integer. So character comma integer will be my value. And we need to keep a name for our map. So what will we keep our name? I'll keep it as R to I. That is Roman to integer. This is our map name. And we need to give it values. Now how are we going to give it values? It's an array of key value pairs. So I'll just write this. I have one question. One of you have asked which is better, include individually or use bit/std++. I would always suggest individually, because some compilers, some online compilers will not allow you to use bit/std C++. They want you to particularly use individual ones. There are some companies which don't allow you to do that. Some do. So it depends purely on company. So to be on the safer side, we always end up using individual header files. I hope that gives a good idea for us. But that's actually a good logic as well, to be honest. Let's go ahead and take a look at this. So here's what we need to do here. So in our case, I need to give key value pairs. What's the key here? I. And what's the value for I? 1. So this is the key value pair. It's an array. Within this array, we have all these array elements. All the elements in our array is like key value pairs like this. So we're going to copy this. So I'm just going to go here so that you guys can see this clearly. Just so that you can see this clearly. Alright, so I, and then let's go for V, and then let's go for X, and then let's go for L, and C, and then G, and we still have M at the end. So for each of this that you want to search, remember the advantage here is your entire time complexity for searching is big O of 1 instead of big O of n for a regular search, that is linear search, or big O of log n for, let's say, binary search. So most of us, when we start learning these things, we find them difficult. When we start learning, let's say, things like this, we find them very difficult. I think a few of the students who are currently answering, who are from our sessions, from our batch sessions already, know the concept of hashing really well, because we have done that in our competitive coding videos, we have done that in our competitive coding parts, and we have just taken a little introduction to it in other sessions as well. So those of you who know it very well, we have gone through its mathematical operations also in our competitive videos. But for those who haven't gone through our sessions, who haven't been in our batches, not to worry, I'm just giving you guys a very small introduction to this for now. Now, let me change the values here. That's done. Now that it's done, let's just go to the string and let's go ahead. Now I need to create a loop. The loop is, before the loop, I need to create my result, right? Remember, what should the result store, guys? String result should store last character. The result should be storing last character initially. So I'm going to write it as last character. That is str of str.size -1. This is our last character. You have to use str of size -1. Str of size will give you the entire size, and str of size -1 gives you the last index. If you don't want to use this and perform one more subtraction, you can directly use str.back. str.back is a function which gives you the last index directly. Last element directly. You don't even have to do any of this. Str back will give you the last index directly. So if this is your string, it will give you the last index directly, which is v. Now when I get v, what should I store in my result? Sorry, result should be an integer, right? We need to convert it to integer and return. Since result should be an integer, I need to store whatever is in str.back. If str.back is v, I need to get the equivalent value of v here in our map and get the 5 value over there. So to get that 5 value, I'm just going to write r to I of the index itself is str.back. str.back will give me the last character. That character is the index here. For that index, whatever is the value, we'll get it. Since it is unordered, it is hash based. That means your search complexity is only 1. Since it is 1, it is negligible. We don't even consider it. It's that negligible. That's it. So this is how we can get the last value as our initial sum or initial result. Now let's go ahead for int I equals str.size -2, not -1, -2, because last index is already stored in result. I'm starting from last second index. This is my I value, which is incidentally I as well. So we're going to start from here. We're going to take this condition I greater than equal to 0, I minus. That's it. Now what do we do here for each of the case? We need to compare if str of I is greater than, is less than str of I plus 1. If it is less than str of I plus 1, what do I need to add to result? I need to add or subtract. If you guys remember, if it is less than its next value, we need to subtract. So I'm going to write result minus equals, what do I need to subtract? I need to subtract whatever is this str of i's equivalent value. How will I get str of i's equivalent value? R to I of str of I. That's it. That's our entire logic. That's it. Entirely done. Else, what do we need to do? Result plus equals R to I of str of I. If it is equal to or greater than, we add, otherwise we subtract. Once this is done, we just return the result to be printed. That's the entire logic. Let's see if it works. We're not sure. Let's check if it works. Let's compile this. Let's see if we get any errors, if we missed out on anything. We haven't. So luckily our code compiled at the first run. So let's run this. I'll give mcmxciv. It's supposed to give me 1996. Is the output correct, guys? Something went very, very wrong, right? Something went very, very wrong in this logic. We have no idea why, but something went very, very wrong. Now, let's take a look at this. Let's quickly take a look at this as to what went wrong. Now, let me ask you guys, should I compare string of I and string of I plus 1? Let me ask you guys the question. Should I compare here? Sorry, it's not absolute. It's not about absolute because the logic where we went wrong is something else. Should I compare string of I and string of I plus 1? Should I compare like string of I is less than string of I plus 1? Or should I compare string of I, which is R to I value? R to I value of string of I is less than R to I value of string of I plus 1. Which one should I do? If I do this first one, it will compare ASCII values. According to ASCII values, it says C is less than M. M is less than X. According to the ASCII value comparison, it thinks 1000 is less than 10. Since 1000 is less than 10, it's going to go all the way to negative. Our logic will entirely fail here. Because when you compare str of I minus str of I less than str of I plus 1, they are character arrays. When you compare character arrays, it will compare their ASCII value. According to this, if I is here, ASCII value of M is less than ASCII value of X. Since ASCII value of M is less than ASCII value of X, it's going to perform subtraction. We don't need to do that. We need to compare its actual integer value, right? Integer value of M is 1000. Integer value of next value X is 10. It's not less than. That's why it should go to else. So what we are doing here is an entirely wrong logic. We need to change this to R to I to solve our logic. So these are some simple things that I'm giving you guys. We intentionally took this little mistake to begin with, and I just wanted you guys to see and just observe where we went wrong, where we could go wrong and everything. So logically it would be correct, but your test cases will fail. Most of your test cases will fail. This is how such a scenario, such a thing can generally happen. Let's give this scenario now. Now did we get the right value? Yes. Let's try again. Perfect. So it works in every scenario. So this is our C++ program using maps to perform conversion of Roman numerals to integer within time complexity of big O of n only. No n plus n log n or n times n searches or anything like that. This is our simple logic. So the previous program and this program I'm going to copy here for your reference. What I want you guys to do by the next session is see if you can try to convert this particular program, which we just did today, into Java and Python. So I hope it was easy. So I hope we made it simple for you guys. I have one question. What if we give other value not there in map? Since the key is not there, what do we need to do? We need to change the key value either gives you a default value or gives you an error depending on programming languages. So different programming languages work in different way. Some give a default value, some give an error. I have one question: how to do how to do integer into Roman numeral? Very simple logic. Here, you need to first figure out what is the, you need to basically reverse the integer and perform it. That's one of the best logics to do, because when you're doing integer to Roman, you need to either reverse it or you need to convert that integer to string and take one element at a time and do it. Like element at fourth place, element at fifth place, that is 50,000, 30,000, 40,000, and all these things you'll get to understand and do it. That's the idea. So you can think about it. By the time, I'll just share the link for you guys. Okay, so the link will be shared in just a minute, please, in just a couple of seconds, so you can have access to this. So yes, it's glad to hear that many of you are finding it easy, but you guys can definitely give this a try. You guys can definitely try to work through this and see how it works, see how to solve such programs. You can try to figure out more and more programs by yourself. The more programs you try to do by yourself, the better you'll be at the logic anyway. So keep practicing as much as possible. I would also request you guys to try the same in Java and Python, see how they work. We'll solve it tomorrow. And those who are really interested in learning hash, you can go through any math books and learn what is collision handling techniques for hashing, and you'll get a really good idea how they work. So they're used in a lot of cases in the real world, even in concepts like blockchain and everything. We do use it. I have one question. How R2I of string of I will take value instead of key? At Shriya's question, see, R2I, consider R2I like an array. Okay, in this array, this key itself is the index. Key is the index, the value, whatever pair along with it, that is the value. So consider this as the index and this as the value. Instead of indices being 0 to n minus 1, these are your custom indices. So with this custom indices, whichever index you want to move to, you can directly move to that. Think of it in that way. That's how it works. That's why R2I of the index as a character, that is the key, we get the value. It's just like the concept of dictionary, where you search for a word and get the meaning of the word. It's the same thing over here. So I hope that gives you a good explanation to begin with. So with this, we'll end our session here. And no, there's no concept of base address over here. Remember, we performed modulus. It works based on modulus logic. There's no base address. Don't compare this to array in that sense. I've compared it just to show that key is similar to index. But there's no such thing called base address or anything, or there is a base address, but it's not like you add addresses and go ahead with it, because the way this works is slightly different logic. We perform modulus in a slightly different way. So you can think of it like that. So for those interested, definitely go check out how hashing works in detail. Or if you're already in our Quantmasters sessions, Quantmasters batches, you can definitely check our competitive coding videos, where we've explained hashing in way too much detail. So with this, we'll end our session here. We'll catch up in the next class. Hope you guys had a fun time here. We'll see you guys later on. Take care, guys. Have a good time.